Now we can go ahead and create an OLAP database. If you remember, we saved a backup. We have a backup of the raw data when we initially created a pipeline and loaded tables into SQL Server. Now we have that big backup file, and we can restore that, and on that create an OLAP database. But before that, let's go ahead and rename this OLTP database as mentioned here, that this is an OLTP. Thus we could distinguish databases. Let's do exec sp rename db my shop Okay, let me refresh databases. Okay, now we have an OLTP database. Now let's restore the initial database. If you remember, we have a backup of that raw data. Let's do restore. It's on device. Let's select device. This one. Okay. Fine, now we have successfully restored the initial database. Let me show that. This is new restored database. Tables are in here. Let me see. Let me open this one. So this was our initial database which we had. Now let me copy this database. Let me start SQL Server agent. I want to copy this one. I will name that as OLAP, and we'll transform that database into OLAP database, and the other one will be just on server. I will not do anything with that. Okay, this one. So now we have the copy of the raw data. Let me refresh this. So here are three databases: OLAP, OLTP, and raw database. I will keep all of them, and of course OLAP I'm going to transform into OLAP. Let me close those and start. So let's at first create a diagram. Oh, actually I forgot. We need to change the names. We need to rename tables. At first, let me, and we have issues in column names also. because I remember that there was a space instead of underscore, so we need to replace spaces with underscores. Let me sorry, product name is correct, is written correct. Okay. Now we can move to creating a diagram, database diagram. And okay, so what is an OLAP database? It's essentially a database where first of all tables are not in normal form. This is for analytical purposes. So in OLAP databases, usually data query execution is slower because those are not normalized, but this is good for analytical purposes. So we should have aggregations. So in OLAP databases, the structure is the following. There should be a fact table and dimensions. So fact tables are in fact table we include measures, all measures, let's say amount, quantity, and etc. And in dimension tables we should have information which describes this data, which describes that fact table. So let me create such a table. We can have there are mainly two types, snowflake and star schemas. So let me decide what I should do. Customer, let me save this diagram. Let me write OLAP diagram. Okay, so basically we can do, at first we need to, I think, rename this ID to be employee ID. Let me okay. Then now let me replace employee name with employee ID. Actually, let's at first delete employee address, alter table employee, sales data, drop employee address. Oh, forgot, drop column employee address. Then let's replace employee name column, I'll update sales data, set employee name select is equal to select employee ID from employee, where sales data dot employee name is equal to employee dot name. Now let's rename employee name table column to be employee IDs, because now there are employee IDs and not names. So sales data dot employee name is going to be employee, or I can write emp ID. Then we need to change the data type also. Alter table sales data, alter column employee ID integer. Let me run this. Okay, then we need to replace product categories. So okay, let's do it first customers, because here in category and products we need to do something else. Let's do at first customers. Let's deal customer name, location, industry. Okay, let's do this now. Here we have customer email, we have customer address. In this customer dimensional table, we don't have email and address, so let's add these two columns to customer table. So let's write alter table customer, add customer address varchar 60 and customer email varchar 60 again. Okay, now let's insert two columns data from this column, customer email and customer address, to customer tables, new added columns. Let's write update customer set. So set customer address is equal to select distinct customer address from sales data, where let's do that. So where, let me name this as S, where S dot customer is equal to customer dot customer name. Okay, then customer email is equal to, let's move to the next row, select, let's copy this command because it is going to be the same. Select, we are going to change only this to email. Okay, where customer name, okay, let's run this command. Now let me check now let me check customer table. Here we should have from customer. Now you see we have customer address and customer email columns. So let me check one more time sales data table. So here we have here we have so customer. We are going to replace this customer column with the IDs, and also we are going to delete these two columns. So let's at first instead of customer names put customer IDs. At least replace those. Let's write update sales data set customer is equal to select customer ID from customer, okay, where customer name is equal to sales data dot customer. Let me run this one. Fine, now we see sales table updated. Let me run this command again, and we see that customer names are replaced with the IDs. So let's go ahead and at first rename this column. Let's write sp rename sales data dot customer. It is going to be customer ID. Then we are going to change data type also, alter table sales data, alter column customer ID. You know what, this is going to be a foreign key. I can, or here, yes, I when I was working on employee, I didn't mention that as foreign key. Let's in this case also let me mention as foreign key later. So let's write customer ID integer, and we are going to drop the other two columns. Okay, let me drop alter table sales data, drop column customer email and customer address. Okay, we dropped. Now let me run this statement again, this query again. Okay. Oh, we don't need industry also. We need to drop industry column also, because industry column is included in customer table. Let me open up. Here we have an industry column, so let me drop this column also, sales data, column industry. Okay, now we can move to products table. Here we have category ID, we have here category, so we can product name, product ID. So we need to have product ID instead of product name and product category. Okay, so we can drop these two columns and have product ID instead of that. Yeah, but I have product cost and product price. I think I will keep product cost and selling price because in products table, because those are not changing over time, and I'm not going to analyze these two numbers. Let's say if I wanted to compare what was the average price or cost in previous periods, that would make sense to keep those in fact table. But because in my case, in this case, there were not any changes over time in price and cost, I will keep those in dimensional table. So I will now replace product name, product category, product cost, and product price, these two columns, with just product ID. Okay, so let's start from category table. Let's update category column in products table with category ID. Let's do now. Let me write update products set category is equal to select category ID from a category table. Category, okay, where category dot category name is equal to products dot here I should have category, this one, first one, category. Okay, let me run this. Now let me rename exec sp rename products dot category or category name. Category, this is going to be category ID. Now let me change the data type also. Alter table products, alter column category ID integer. Good. Now let's move to sales table. Let's move to I can replace this product name column, update sales data set product name is equal to select product ID from products where let me given else this p dot product name is equal to sales data dot product name. Then we can rename again. Rename sales data dot product name. Product name is going to be product ID. Let me see what we have in sales data table. Select top 10 from sales. Transaction date, payment card, monthly key, employee ID, customer ID, product ID, product category, product cost. Yes, these three are going to be dropped. Alter table. Let's identify before we drop product ID for this product. Okay, let's open up products table. Product ID is 29. So for this product, we have category ID 4. So let me go to category table and check the fourth category, beauty and personal care. We see beauty and personal care. So let me close those two. But actually I need to, I think, rename this cat ID because I found it pretty late. So let me rename, and here let me write here category ID. Okay, let me close this. Then I'm going to drop these three tables: alter table, sales data, drop column product category, then product cost, then product price. Okay, now we have another table. This is marketing expenses table. Actually, let me open up that table and show what we have here. Here are expenses, marketing expenses by month, by year and month. So this is actually a measure because this is for me as historical data, and I'm going to analyze this by dates, by month, and actually this I want to move to fact table. So but here the problem is the following, that my expenses, let's say this expense is written for in the whole month, but here my transactions are by dates. Look, date, this is the same date. So I think I need to actually let me do order by transaction ID here. So I think I need to divide. Look, this is starting from January 1st. I need to divide this $1,000 to the count of rows, I think by month year key, because month year key is unique. Let me now add another column where I will keep data about marketing expenses. Sales data, add monthly marketing expenses. This is going to be float because when I will divide monthly expense by the total quantity of transactions related to particular month, in any case I will get float value. So now let me run this one more time and see what we have in this marketing expenses, monthly marketing expenses column. I'm going to get the portion of each transaction related to this particular month. So let me use a common table expression. Let me write city as, so let me at first get marketing expenses by month and get the quantity of transactions by each month, then divide the amount to quantity. So let's do select month year key, then let me select also marketing, how it was written in marketing expenses. Let me open up this column, month year key, and marketing expenses, from this table. Then I'm to get the quantity, I'm going to join. Let me name this as M. I'm going to join also sales data table. So join sales data as S on S dot. I'm going to join by month year key, M dot month year key. Then from this sales data table, I want to get the total quantity. So let me write here M dot. Let me write here M dot again, and I'm going to get the total count. So count, let me write S dot month year key, and I need to group by. So let me name this as transaction quantity. I can name this like this, join sales data. Okay, then I need to group by these two columns. Let me do okay, copy, group by these two columns. So let me run this and see the result. Okay, this is exactly what I want. For this particular month year key, I have $2,400 of expenses, and the total transaction is this. So I will do here update sales data. So set how we called monthly marketing expenses. So set this column as equal to, so I'm going to divide STE dot marketing expenses by transaction quantity. Transaction quantity. Okay, so but I need to join this common table expression also to understand which month expense will take and divide by which month transaction quantity. So let me write here from sales data join. So join common table expression on So sales data dot month year key is equal to ct dot month year key. Okay, let me run this query. Okay, so let me cut this and bring to here. Let me check the result. Okay, let me write select month year key, then sum of monthly marketing expenses from sales data group by okay. Now we see that we got correct amounts. Let me open up this table and see, for example, let me order by here order by month year key. For example, for this month, for January 2014, we did $1,000 expenses, the same amount, 1400, 1st of December 1400. Okay, so now we have all measures in fact table. Then I need to decide what to do this with this marketing expenses table. I don't need this. I will drop this entire table, and instead of that I will create, or I can just load into database a calendar table which will contain years, months, days in that. But at first let's drop marketing expenses table. Drop table market expenses. Okay, now let me load the calendar table in real quick. That calendar table we can also generate. We can generate in SQL Server. We can generate in Power BI as well. But I have one. Let me let me show that table, how it looks like. Here we have dates. Dates are starting from 2013 year. Our database starts from 2014 year and till 2026. Here we have month, so this is January, first month. We have week of year. This is those are first week of that year till the end. For example, this is 48th. This is 48th week of the year. Then we have days here. For example, this is February 2013. In that month we have 28 days, and this is day of week, Monday, Tuesday, and etc. So let me go ahead and load that in real quick. By the way, in our database we have only one in this OLAP database we have only one date column, which is in sales data table transaction date column. But if let's say we had shipping date, order date, transaction date, and other dates, we need to have as many calendar tables as we have columns of dates. So we need to use for each column separate tables, because it is not correct to reference from one calendar table to two other date columns, let's say shipping date and order date. That's not correct. But because we have only one date, we don't need to have other calendar tables. So this is Excel. I will name this as calendar top, like this. Here we need to have date, for month we need to have integer. All these are integers. Let me check. Let me refresh tables. Let me open up calendar table. The next step is creating relationships. Sales data. Let me define this transaction ID as primary key. Alter table sales data, add primary key transaction ID. Okay, let me set that as not null. Alter table sales data, alter column transaction ID not null. Integer not null. Okay, now let me define as primary key this employee ID table in employee ID column in employee table. Let me check if that set. Yes, it is set null. So let me write alter table employee, alter column employee ID integer not null, employee ID. Okay, employee ID not null. Now let me define that as primary key. Okay, now let me define customer ID in customer table as primary key. Okay, alter table. Here we need to write customer. Then we need to copy this for customer and write add primary key. Oh, customer ID. Okay, let me group those commands together. So here let me delete this. Okay, for sales table. Okay, then I need to define product ID in products table as primary key. It is also null, so products product ID. Here I need to change also products. Okay, let me run those two. Okay, then category ID in category table. So category ID, and here so the next table is calendar table. Let me copy these two, put it here, and write alter table calendar, alter column date, and here again calendar, add primary key on date column. Oh, sorry, calendar tab should be written. Oh, sorry, it was date. The data type of this column was date, not integer. Okay, so now we defined primary keys for the all tables. Now we can go ahead and establish relationships between tables. So we can start from calendar table, alter table. All these dimensional tables should be referenced to the fact table, to sales table. So every time we define a foreign key in sales table, so alter table sales data, then add constraint foreign key. Now we can write sales calendar. Okay, foreign key, so date calendar table date column. Oh, here we need to write transaction date, foreign key transaction date. Good. Now let me copy this and paste it here and edit for customer table, alter table, add constraint. Here we need to write customer. Here we need to write customer ID, but how it is written, cust ID. So references to customer tables, customer ID, customer ID. So let me run this one also. Good. Now let me copy this, paste it here, and sales products, we can do sales with products. So let me write here products. Products foreign key is going to be product ID, and here also column name is product ID. So product ID, okay. Then let's establish a relationship between products table and category table. So let me write here alter table products at constraint category. Foreign key is going to be category ID, and in category table also written category ID. So category ID, and here category table, category ID. Okay, so now let's move to I guess employees table. Let me go to diagram. Yes, we can move to employee table. So add constraint sales, here we need to write employee, foreign key emp ID, emp ID references to employee table, employee ID, employee ID. Okay. Now let me create an updated diagram. Okay, so this is the expected result. We have a fact table and dimensional tables connected to that. I can do like this, move it here. Okay, so this is snowflake schema. Of course this is too small, but in any case this is rather snowflake than star. So that's all. We have created an OLAP diagram. We can of course do optimizations here. We can create indexes and etc. But overall this OLAP database is for data warehouses. This is not for day-to-day operations, so we will keep this in data warehouse and return to that for analysis if we need some analysis. So I want to say that maybe it depends on do we need optimization or not. It is not a must that in any case we should do an optimization. We should create indexes here on that, because maybe if that indexes will not play a role, why we need to create indexes if we are not going to query this data every day. So it depends on particular case. I will go ahead and create an OLAP cube based on this.